You have surely seen photographs of Mars, a red desert covered in dust and stones with silent ridges stretching to the horizon. In these images, taken by the Perseverance rover, the planet appears utterly lifeless. And yet, it is within this silence that the intrigue lies. Very recently, NASA announced that rock samples collected by the rover in Jezero crater may contain traces of ancient life. Jezero crater is the dried bed of a river where billions of years ago water once flowed. Scientists chose this precise location for the rover's landing because sedimentary rocks, which often preserve microbial imprints on Earth, could have been preserved here as well. When Perseverance drilled into a stone and extracted its core, researchers observed unusual structures, spotted patterns that they called leopard spots. Within these spots were minerals often associated with life on Earth. One was vivianite, a greenish iron phosphate that usually forms as plants and animals decompose. Another was graphite, an iron sulfide that under terrestrial conditions is sometimes synthesized by bacteria. This is not yet proof, but it is precisely the kind of spark that could change our understanding of the universe. Nicola Fox, head of NASA's science programs, emphasized that what we are dealing with here is a potential biosignature. In science, a biosignature refers to any molecule or structure that may have been created by a living organism. Yet every such discovery demands caution, because minerals can also arise without life's involvement. That is why the entire scientific community now awaits a more detailed analysis. According to Reuters, Joel Hurowitz, an astrobiologist and professor of geochemistry at Stony Brook University in New York, is the lead author of a study published in Nature that presents the analysis of a sample collected by NASA's Perseverance rover in Jezero crater. This sample, nicknamed Sapphire Canyon, contains minerals such as vivianite and greigite, which on Earth are often associated with microbial activity. Hurowitz and his colleagues believe these minerals may have formed through biological processes that took place on Mars roughly 3.2 to 3.8 billion years ago, when the crater was still a lake. However, the scientists stress that more research must be carried out on Earth before any final conclusions can be drawn, since similar minerals can form without life. Hurowitz notes that it is the combination of carbon, sulfur, and phosphorus in Martian samples that looks particularly promising. On Earth, these very elements serve as fuel for bacteria that thrive even in the harshest conditions. Picture a swampy peat bog, where plants slowly decay beneath layers of water cut off from oxygen. Even today, one can find vivianite there. Or think of the sulfurous hot springs of Iceland, where microorganisms synthesize minerals resembling those discovered by Perseverance. Such earthly scenes help us imagine what ancient Mars may have been like. Mars has long stirred human imagination. In ancient Babylon, it was linked with the god of war, Nergal, while in China, it was called the Fire Star. Today, however, we explain the planet's red color quite differently. Iron in the Martian soil has oxidized, and this rust paints the planet blood red. But if you look closer, as Perseverance did, you can see more than red. There are greenish mineral shades, yellowish sulfur streaks, dark blotches that look almost like the remnants of someone's breath. What is most striking is that Earth itself gives us the keys to unlocking Mars. Scientists use the term analog sites, regions on our planet whose conditions resemble those on Mars. For example, the Atacama Desert in Chile, where no rain falls for years and where ancient bacteria hide in the rocks. Or Antarctica, where life persists under kilometers of ice. These places demonstrate that life is extraordinarily resilient, finding ways to exist in environments we would never imagine. And if life could persist on Earth under such harsh conditions, then why not on Mars billions of years ago? This question feels especially urgent now, as scientists hold in their hands, for the first time, samples with potential traces of it. It is a moment comparable to an archaeologist uncovering a strange shard in the ground and realizing perhaps this is part of an ancient civilization. If you too feel that shiver of awe when it comes to the search for life on other planets, support this channel. Give this video a like right now. For it is precisely such discoveries that remind us we live in an age when the history of humanity could change before our eyes. Today, hundreds of scientists work in the field of astrobiology. Among them is Carol Stoker of NASA's Ames Research Center, who has spent decades studying microorganisms in Earth's extreme environments, with every dataset adding weight to the argument that life could once have existed on Mars. Carol Stoker is a senior research scientist at NASA Ames, specializing in the search for life on Mars. Her work spans extremophilic microorganisms capable of surviving in Earth's harshest conditions: hot springs, saline lakes, Arctic wastelands. These organisms serve as models for seeking life on other planets. She has led projects such as the Mars Analog Research and Technology Experiment in Spain, which studied the geochemistry of the Rio Tinto River, reminiscent of Martian environments. She also participated in the Mars Pathfinder and Phoenix missions, developing technologies for life detection. Her projects have received 6 NASA Group Awards, and she is the author of over 100 scientific publications. She says that the search for life is not only a scientific question, but also a question of self-understanding. If we discover it, even just a tiny bacterium, we will have to accept that life is not Earth's unique miracle, but a universal law of the cosmos. And perhaps this thought is the most important of all, because every new discovery carries not only scientific sensation, but also philosophical challenge. What does it mean to be human in a universe where life could exist everywhere? How will our culture, religions, and self-conceptions change if we cease to be the only living beings? When we speak of the search for life on Mars, we cannot ignore the theory of panspermia. It sounds like science fiction, but it has been discussed by scientists for over a century. The idea is that life may spread through the universe like seeds in space. Comets and asteroids striking planets could deliver microorganisms. This idea was already popular with the ancient Greek philosopher Anaxagoras, who believed that life came to Earth from the cosmos. Around 500 years before our era, Anaxagoras proposed one of the earliest systematic theories of the origin of the cosmos. He envisioned all matter as composed of a seeds of all things, or homo eumeres, contained in a motionless, primordial mixture. Into this chaos, nous, translated as mind or intellect, introduced order and set it into powerful circular motion. This vortex caused components to separate, and dense masses began forming at the center of the cosmos, giving rise to Earth. According to Anaxagoras, stones could detach from Earth's edge, heat up under the fiery ether, and begin to glow. He considered the Sun to be the largest of these incandescent masses, and the stars smaller stones held in place by centrifugal force. Of course, today we have far more precise and wide-ranging knowledge of the cosmos. Modern astronomy explains the formation of planets and stars through physical processes such as accretion, gravitational interaction, and thermonuclear reactions. Yet Anaxagoras' theory is impressive in its depth for its time. The idea that the cosmos was ordered by mind and that matter contained the seeds of future forms reveals an early philosophical attempt to comprehend the universe. Even now, his ideas remain an inspiring example of how philosophical intuition sometimes anticipated scientific discovery. It is worth noting that Anaxagoras' notions of the seeds of all things and the role of mind in shaping the cosmos, though philosophical, strikingly resonate with modern ideas about the origins of complex matter in the universe. At its core, it is the drive to understand how order arises from chaos, how simple components evolve into complex structures, including those that could become the basis of life. In the 20th century, Sir Fred Hoyle, the renowned British astrophysicist, returned to this notion. He argued that interstellar dust might contain complex organic molecules. Modern research has partially confirmed his intuition. In samples collected from Comet 67P Churyumov-Gerasimenko during the European Space Agency's Rosetta mission, scientists discovered organic compounds, including amino acids, the very building blocks of life. The comet was named after two astronomers who discovered it. In 1973, Soviet scientist Klim Churyumov, working at the Crimean Astrophysical Observatory, noticed an unusual object on photographic plates prepared by Svetlana Gerasimenko. Upon closer study, it turned out to be a new comet moving along its orbit, and by tradition, it was named after both of them. Officially designated 67P, the comet lies in the belt between Jupiter and Saturn, hundreds of millions of kilometers from Earth. It has a distinct rubber duck shape, with two lobes joined together, and consists of a mixture of ice, dust, and rock. It travels around the Sun in an elliptical orbit of about 6.5 years. Its surface is coated with a dark, carbon-rich layer, and as it approaches the Sun, ice begins to evaporate, creating a gaseous coma and a dust and gas tail visible even from Earth. In 2014, Rosetta's Philae lander became the first spacecraft in history to make a soft landing on a comet. Equipped with a drill to collect surface samples and tiny ovens for analysis, it provided data that revealed organic molecules, including the amino acid glycine. This confirmed that substances essential for life can indeed be found in space. If we accept that life on Earth may have arrived through cosmic delivery, then it is not impossible that Mars too may have been part of this grand exchange. NASA Ames senior scientist Christopher McKay has dedicated decades to this topic, studying whether Martian conditions could support even the simplest forms of life. McKay notes that billions of years ago, Mars was warmer and wetter than today, with lakes, rivers, and perhaps oceans. In his view, it was then that life could have originated, some of it possibly transferred to Earth via meteorites. History offers real examples of this. In 1996, a famous meteorite called ALSL 841 was found in Antarctica. Its age was estimated at over 4 billion years, and it originated on Mars. Inside were microscopic structures resembling fossilized bacteria. The discovery sparked intense debate. Some scientists considered it proof of Martian life. Others argued the shapes could have formed without biology. The controversy continues to this day. This debate reminds us how difficult it is to provide definitive answers, for nature often creates illusions of life. Yet even the possibility that ancient Martian microbes once landed on Earth compels us to reconsider our own origins. Imagine that your distant ancestors may not have been born on the blue planet, but on the red one. Imagine that humanity is, in some sense, of Martian descent. The thought is at once enchanting and unsettling. It shatters our familiar sense of home, but grants us a deeper connection to the universe. Scientific discoveries often intertwine with personal stories. One young graduate student in McKay's lab recalled that when he first peered through a microscope at frozen Antarctic soil samples, it felt as though he was gazing at another world. He realized he was studying not merely icy crystals, but a kind of mirror of Mars. In such moments, you sense that science is not only data and formulas, but also an inner tremor. We humans have always sought our reflection in the universe. Ancient philosophers asked whether we are unique or part of a greater order. Today, scientists attempt to answer the same questions with complex instruments, spectrometers, and rovers. But in essence, it is still the same search for meaning. This is why it matters not only to read about such discoveries, but to discuss them, to share reflections. If you enjoy pondering who we are and where we came from, write about it in the comments. Perhaps your thought will become part of this conversation. From a scientific standpoint, every step toward understanding Mars also opens practical horizons. McKay and colleagues have shown that Martian soil could potentially support plant life. In experiments on Earth, using soils similar to those on Mars, these researchers succeeded in germinating plants. This means that colonies on Mars are no longer just science fiction, but the subject of serious calculation. But before we go there, we must answer the central question: is there life? For if it exists, we must build the future with that coexistence in mind. In this sense, the Perseverance rover is not just a scientific instrument, but humanity's first diplomat, establishing contact with a planet that embodies both our dreams and our fears. Here we encounter a remarkable paradox. The more we study Mars, the more we understand ourselves. For life on Earth too once arose from the chaos of chemical reactions. And unraveling Martian processes gives us keys to our own origins. When scientists lack answers, they begin to build models. To determine whether life could have existed on Mars, we must recreate Martian conditions here on Earth. For this, unique laboratories are built, so-called Mars simulators. These are chambers where pressure, temperature, radiation levels, and atmospheric composition can be controlled. One such laboratory is at the University of Arkansas, where astrobiologist Terence Hines and his colleagues have for years studied how microorganisms behave in conditions as close as possible to those on Mars. In these chambers, air pressure is nearly 100 times lower than on Earth. Temperatures drop below -60 degrees, and the atmosphere consists mostly of carbon dioxide. Yet even in such extreme conditions, some bacteria manage to survive. This discovery is astonishing. We tend to think of life as a fragile flame, extinguished by the slightest breeze. But in truth, life is stubborn and inventive. It is like a river that always finds its way, even when blocked. That is why the study of microorganisms in Earth's extreme environments is a window into Mars's possible past and future. German scientist Dirk Schulze-Mackach has devoted his work to extremophiles, creatures that live where life seems impossible. He studies bacteria that survive in acidic lakes, in radioactive mines, in the lightless depths of the ocean. These organisms are like hints from nature itself, telling us not to confine life within the boundaries of the familiar. The story of how living microbes were found in Lake Vostok, beneath 4 kilometers of Antarctic ice, has become a symbol of life's resilience. For thousands of years, that world was sealed off. Yet bacteria endured there, drawing energy from chemical sources. Scientists are convinced that similar mechanisms could exist on Mars, where water may still be hidden beneath the surface. For now, Perseverance explores only the surface, but scientists dream of drilling missions that could penetrate deeper. For beneath the soil, life would stand a greater chance, shielded from radiation and cosmic winds. It is like a traveler escaping a storm by retreating into a cave, waiting in shelter until the tempest passes. Life on Mars may have done the same, burrowing inward. We often think of space as distant, but it is here, on Earth, in laboratories and deserts, that scientists pave the way to understanding another planet. In Chile's Atacama Desert, experiments with Martian rovers and instruments take place because the local climate is so dry that it mirrors Mars. There too, researchers found microorganisms capable of surviving with almost no water, a vivid argument that Mars could once have harbored life. Sometimes discoveries arise from chance observations. A young researcher once left a flask of bacteria in a Mars simulator longer than planned. By all calculations, they should have died. Yet months later, when he opened the chamber, living cells remained. For him, this moment symbolized how life is always one step ahead of our predictions. This is why the search on Mars is not only a scientific mission, but a philosophical one. We ask ourselves, where are the limits of life's possibilities? And if we see that the limit keeps shifting, then perhaps life itself is a universal force, striving to fill every void in the cosmos. Such reflections can inspire anyone. For if a bacterium can survive where survival seems impossible, then surely a human being can endure challenges that seem insurmountable. In this sense, the science of Mars becomes a metaphor for our inner resilience. That is why I invite you to like this video. Every gesture of support is a small signal to the researchers working on humanity's greatest questions. Together, we create a space where science is not dry text, but a living dialogue. Today, experiments in Mars simulators already go beyond bacteria. Scientists are attempting to grow plants, test materials for future bases, model breathing systems for astronauts. It is like a rehearsal before stepping onto the stage. One day, when a human sets foot on the Martian surface, they will be using knowledge born today in quiet, earthly laboratories. And perhaps it is in these very laboratories that we are already approaching the answer to the ultimate question. If life could exist on Mars in the past, then it may have survived until now, which means that our generation may be the first to discover it. Mars has never been just a planet. It has always been a mirror of human dreams and fears. When in the 19th century, the astronomer Giovanni Schiaparelli saw long lines on Mars and called them canals, it marked the beginning of an entire era of imagination. Here is how it happened. In the year 1886, the Italian astronomer Giovanni Schiaparelli, observing Mars through a telescope, noticed long, dark lines across its surface, which he called canali. He used a relatively powerful telescope for that time and made detailed sketches of Martian features. Schiaparelli believed these lines to be natural geological formations, though his Italian word canali meant channels, not necessarily artificial constructions. Later, however, in English translations, the word came to be understood as artificial canals, which gave rise to the legend of intelligent Martians and ignited fierce debates among scientists and popularizers of astronomy. The American science popularizer Percival Lowell convinced the public that these canals had been built by intelligent beings trying to save their dying planet. His books inspired generations of readers, though it was later revealed that the canals were nothing more than an optical illusion. Science fiction eagerly embraced the idea. In 1898, the English writer Herbert Wells published his novel, The War of the Worlds, which quickly became a sensation. He presented the story of Martians invading Earth with a scientific, almost documentary approach, describing their technological capabilities, their giant war machines, and the devastating effect they had on human cities. Wells was inspired by the latest astronomical discoveries of the time, including Schiaparelli's observations of the Martian canals, and he reflected on how a more advanced civilization might confront humanity. His novel combined fantasy with scientific thought, stirring in readers both horror and awe, and his imagined Martian technologies became prototypes for countless works of science fiction that followed. This story was not only a terrifying dream of an alien civilization, but also an allegory of colonialism and the vulnerability of humankind. When, in 1938, a radio dramatization of the novel was broadcast, thousands of people believed Martians were truly attacking, and in panic, they rushed into the streets. It became an example of how deeply the image of the Red Planet resides in human imagination. But Mars is not only about the fear of the alien, it is also a symbol of hope. In the 20th century, the Soviet writer Alexander Kazantsev dreamed that one day we would find brothers in mind there. And Ray Bradbury, in The Martian Chronicles, transformed Mars into a poetic symbol of longing and loss, where each story was a meditation on human nature. Philosophers, too, did not overlook the question. Carl Sagan, the great astrophysicist and science popularizer, often said that the search for extraterrestrial life is, above all, a way to understand our own place in the cosmos. In his book Cosmos, he wrote that if we turn out to be the only living beings in the universe, it would be an awful waste of space. His voice still resonates in the ears of many researchers as a reminder that science and dreaming are parts of the same path. In art, Mars often becomes a symbol of another home. In films and novels, it is the planet where we search for a reflection of ourselves. When director Ridley Scott made The Martian, he did not show an encounter with alien intelligence, but instead a story of human resilience and inventiveness. The main character, stranded alone on Mars, survived thanks to knowledge and determination. And that was the most important message. Life can endure if we bring together science and hope. These stories teach us that the search for life on Mars is not only a scientific project, but also a cultural journey. On Mars, we see not only rocks and sand, but also our own fears, hopes, and dreams. In this sense, Martian discoveries are part of our spiritual history. One could say that Mars is a kind of screen onto which humanity projects its visions of the future. The question of whether there is life there sounds very much like the question of who we ourselves are. If life is found, then we are not alone. If not, then it is up to us to bring it there. I would like to invite you to become part of this conversation. Write in the comments how you imagine Mars. To you, is it a planet of deserts and cold? Or, on the contrary, a symbol of humanity's future? Each of your words is a contribution to the common story we are writing together. It is striking that the very idea of searching for life beyond Earth is changing our thinking. We begin to realize that we cannot look at ourselves in isolation. If life is possible in other corners of the universe, then we are only part of a vast pattern. This frees us from the illusion of being the center of the world, while giving us a much broader perspective. Philosophers of the past sought foundations in religions and myths. Modern philosophers and scientists seek them in the cosmos. This does not cancel spiritual quests, but it adds new horizons to them. Humanity has always reached for the sky, and now that striving is becoming the reality of scientific programs. And yet, in this grand picture, we must not forget a simple human feeling. When the rover Perseverance sends back photographs of a Martian sunset, the sky painted in delicate blue shades, it reminds us that even a distant planet can appear astonishingly similar to our home, and in that resemblance, we find hope. Today, when the conversation about Mars sounds less like science fiction and more like a strategy for the coming decades, humanity is preparing for new steps. In the deserts and craters of the planet, rovers are already at work, but they are only the forerunners of larger expeditions. The main goal of the coming years is the delivery of Martian rock samples to Earth. For this very purpose, joint missions of NASA and the European Space Agency are being created. The Perseverance rover is already collecting and sealing soil samples in capsules that one day will be lifted by a rocket from the Martian surface and sent on the return journey. This will not be merely a logistical triumph, it will be a symbolic act. For the first time in human history, we will touch real material from another planet within the laboratories of our Earth. A stone that has lain for millions of years beneath the Martian sky will rest on a researcher's table beneath the thin glass of a microscope. What will we see? Perhaps nothing more than dust and minerals resembling those on Earth, or perhaps structures that will force us to reconsider the question of life. Any finding will become a new point of departure, because at that moment, science will no longer be somewhere out there in orbit, but part of our immediate reality. Ahead lie decades of work, projects for habitable stations, testing technologies for growing food and extracting water, creating life support systems. But all of this begins with the first gesture, with the moment when we bring home a fragment of another planet. Perhaps only then will we truly feel that the boundaries between worlds are indeed permeable.